So my voice is audible.
Yes, sir.
Yes, sir.
So now screen is visible to you.
Yes, sir.
Okay. So in the last 3-4 lectures, we have tried to cover the acrometeorology and crop weather forecasting, some syllabus that is in unit first. First one is the general information about the atmosphere composition, then layering of the atmosphere. In the second lecture, we are tried to the weather, climate, meteorology, and then agrometeorology, scope, aims, and utility of agrometeorology. And the previous one lecture, we have tried to see about the pressure, atmospheric pressure, some part. Today we will going to revision of the some part, and the next part will be covered in the first lecture, and immediately after second lecture of only the 30 minutes or 25 minutes, I will going to conduct, in which we will try to cover the wind. Okay.
Okay, sir.
Okay, sir.
So in this lecture, we will trying to see the definition in its general circulation, vertical and horizontal profile of atmospheric pressure, what is mean isobars and types of the isobars, and the diagonal variations, cyclones, anticyclones, and characteristic of cyclones, then instrumentation. So the weight exerted by air column on a unit surface area of Earth is called as the atmospheric pressure, and this is the formula already we have seen. And the some, just a minute, I have to minimize this. You are able to see the all the screen, na? Okay. So
Yes,
the
sir.
unlike the temperature, pressure decrease exponentially with the altitude. As increasing the height, decreasing the atmospheric pressure, and 80% mass of the atmosphere contains in the lower atmosphere, that is the troposphere. Then gradually increasing, generally measure the atmospheric pressure in the millibar. The different units as given here, that is the bar at this sea surface or the sea level, that is 1 bar is equal to 10-13 millibar, or it is a 1 atmosphere, or it is the 760 millimeter per inch. It is a different expressions of the units of the atmospheric pressure. And again, here is given how it is calculating the 1 atmospheric, that is the 760 mmHg in bar, and the hectopascal and kilopascal and millibar. Then the factors affecting on pressure at a place, that is the temperature, altitude, water vapor in the air, revolution of Earth, and gravitation of Earth. So general circulation is nothing but the different factors, the movement of the atmosphere on the Earth surface. Already you are known, this is the Earth, and this is the sun. Sun is the universal source of the energy, universal source of the heat in the universe. And the you have seen, if the perpendicular to the place, or the uh, completely perpendicular, the energy is more, and the inclination angle of the radiation is covering more area, means getting the less energy per unit area. And due to the heating, or due to the different processes in the atmosphere, this is nothing but the layer of the atmosphere. We have seen the in the composition of atmosphere, different types of the gases, mixture of gases present in the atmosphere and the surrounding of. You are visible to arrow.
Yes, sir.
Okay. So this is
Yes,
the atmosphere of the Earth. So if you are getting the radiation in the straight, that is the energy is more, and the inclination, that is inclined radiation getting receiving to the both the pole, north pole and south pole, means the energy is receiving less per unit area, and the area covered by, and the here is the area covered is less and area covered is more. In this way, the heating in the winter season, this is the winter season heating area of the land of the or the part of the earth, and in the summer season, covering the area of the part. So, in the Arctic region or the polar region, what happens? The incoming radiation is and outgoing radiation is more than the equatorial part, because of the earth heat or the heating of the earth surfaces in the central or the near to the um, equator, that is from the 30 to 30 longitude, that is tropic of Cancer and tropic of Capricorn, the heating is more compared to the pole, and this is the reason for the circulation of the atmosphere on the earth, and the regional variation in temperature causes the different difference in a pressure. Is it right? So because of the heating, the pressure is the difference at the pole, at the center, and at the equator, and the region of the Capricorn and Cancer. So this type of the wind pressure is creating, and the flow of the atmosphere, flow of the wind has happened, and this is called as the atmospheric motion or the wind when summarized over the earth surface. So whatsoever the movement, whatsoever the wind movement in the earth that is summarized or the accumulated is surface is known as the general circulation of atmosphere. If you are asked in the examination, write the definition. Then you write the definition of the general circulation is the atmospheric motion or wind when summarized over the earth's surface is known as the general circulation of atmosphere. And the vertical distribution of the atmospheric pressure is like this, already I told, as increasing the height means increasing the altitude, decreasing the air pressure or the atmospheric pressure. So in this way, the height is increasing means altitude and the density of the air and the gravitational force is affecting on the atmospheric pressure, and the rate of change of or decreasing the pressure as increasing the height is mentioned by the dP upon dH, means change in pressure divided by change in height is equal to minus rho g. Minus sign is given because of the gravitational force considered is the minus. And the horizontal variation of the atmosphere, the horizontal distribution of the pressure depends on the temperature, then extent of water vapor, latitude, and the land water relationship. The uneven heating of the earth's surface already we have seen by the different figures of the earth. Latitude results in a pressure variation, and the pressure and temperature act inverse to each other, as increasing the pressure decreasing the temperature, or decreasing the temperature increasing the pressure. So pressure of water vapor in a air make the air lighter. Already it is explained in last lecture. This is a very important lines. The pressure of water vapor in air make the air lighter. The saturated air is lighter than the dry air, and therefore the saturated adiabatic lapse rate is lesser than the dry adiabatic lapse rate. The horizontal distribution of the atmosphere, there are the 7 layers we are going to see through the figure. So this is the equatorial low. Near to the equator, temperature is more and the pressure is less. So subtropical high and subpolar low, both the north and south, and the polar high north, polar high south. So these are the 7 belts as already explained in this way. Then what is mean the isobars? So before that, going to see the isobars, you have seen the this is a meteorological graph. You are able to see.
Yes, sir.
Yes, sir.
Yes, sir.
This is the map of geographical India. Is it right? So there are seen some green lines, then some pale green, then orange, red. Is it right? And then black lines. So these black lines are for the, this is a low pressure created near the Bay of in the Arabian Sea near the Mumbai, and cyclonic condition is there. This is the picture downloaded from the net, and this is the cyclone of which is cyclone recently we have experienced. Anybody? Anybody? Okay. So in the May 21, there is the one cyclone, disaster cyclone we have experienced, and this is the picture. So the different lines are showing. This is the one passage. So again, here is a one dark green line is there. Is it right? So all these lines
Yes.
is nothing but these are red lines for the temperature. Then these black lines for the wind speed. Likewise. So this showing the line on the map of meteorological map, that is any line joining the places of equal. If you see here, here, this line here, this here, here, then here, there are the equal temperature is there, or equal wind speed is there, or equal pressure is there. What it may be, line may be the different types, and the any line joining places of equal atmospheric pressure, like this black line here is shown, we called as the isobar. And isobar are closely spaced and rapid or steep change in pressure. You see here the two isobars. This is close, and never it cross the isobar to each other, which kept in mind. Then any weather parameter or any weather elements having showing on the meteorological graph, and that stretching a line, sketching a line, that line is called as the isoplates. So a line or curve of equal values of weather elements connected on a weather map is called as the isoplates. So any type of the line, this is the isoplates. You have seen the different types of the lines in different color. These are nothing but the isoplates. So red lines for the temperature. So the temperature line or a curve on a weather map is called as the isotherm. Then the similar points or similar observations connected to each other on a map is called as the isotech when wind speed is there. Then wind direction, streamlines. Then the equal rainfall points have joined to each other is called as the iso height. And the equal cloud line joins on a weather map is called as isoneck. It is very important to all of the competitive examination and also for the our midterm and semester final examination. What is meant by isopletes? What is meant by isobar? What is meant by isotherm, isotech, streamlines, isoheight, and isoneck? It is clear.
Yes,
In this
Yes, sir.
in this lecture, the main thing is that for the point of view, all the examination, it may be the JRF, SRF, or ASRB, or any competitive examination, one question on this always you have seen in the question paper. Then different shapes of the isobars. This assumes that is curve. This is a shape. So when the pressure and different places joining the lines as a different atmospheric pressure and creating the structure like this is called as the shapes. So this is nothing but the low pressure, that is depression. Then there is more depression that called as the low pressure. Then again pressure is going low, that is called as the trough. In the IMD website and sometimes in the summer and in the monsoon season they are using the different trough is developed near the West Bengal in the sea or in the near to the Konkan or the Gujarat in the Arabian Sea. Likewise, the depression, deep depression, and then because of the these are nothing but the meteorological events, or that is called as the uh, cloud physics. So, in the climatological study, there are the different terminologies used related to the pressure, and pressure is decreased or increased. Suppose the pressure at a place is high, it creates the anticyclone. Pressure is low over the earth surface in the atmosphere, create the cyclone. And cyclone is useful to the rain. You have see here the low pressure is here created, and this is due to the frontal zone, means in the summer season hailstorm and the unseasonal rainfall we have many times seen because of the frontal zonation. And frontal zonation means this is a warm air and this is a cold air. So in this region, we are getting the rainfall due to the creating the depression and trough or ridge and col. Another term is the use is the ridge. So more deep depression and a cyclonic condition is there. Then there is called as the ridge. And between two highs, the two locations, the pressure is high. Then in between that two, there are in near about the equal pressure that is called as the col. And straight isobars means likewise there is a no chances of the creating the cyclones, that is called as the cyclones. Already cyclone and anticyclone is covered, so we will see in the next slide again in deep about the cyclone and anticyclone. So diurnal variation in pressure, if you are asking in the examination or any time when the maximum pressure is in general, maximum pressure observed during the day and minimum pressure during the day means 24 hours. So there is one high and one low. So in generally in the temperature, but in the atmospheric pressure there is a two highs, means maximum values getting two times and low values getting twice in a day. So high as a 10 a.m. and at a 10 p.m. and lows means low values at 4 p.m. and 4 a.m. Because of at the evening time and early in the morning, the water vapor present in the atmosphere, that is humid atmosphere, and the pressure is low. So what is the pressure gradient? Pressure gradient is nothing but the rate of change of pressure per unit distance between 2 points at the same elevation, which is known as the pressure gradient or isobaric flow. Sometimes you are asking the isobaric flow. So you write the definition of this, and it is expressed in terms of decrease in pressure per unit horizontal distance as a millibar per 100 meter. So cyclone already it is covered. This is the structure of cyclone, and this is one is the cyclonic condition already. Now just you have asked, but nobody can able to give the answer maybe because the limit of the time. So here the Taukte cyclone has happened in the month of the May, that is 17th to 19th May 21, and this is the picture of the develop. This is a cyclonic condition. Means this is eye of the cyclone, and this is the wall of the cyclone. So here is the pressure is more, then less pressure, then here is a less, again here is a less, and here is a low pressure. When the pressure is low at the center, there is called as the cyclone, and this is a circular or oval isobars. The cyclonic condition, pressure decreases from its outer side to the inner rim. Here rush spirally, that is, if you see here is spherical towards the center, then velocity of air is more, and air circulates in anti-clockwise in the northern hemisphere and the clockwise in the southern hemisphere. Then anticyclone, this is the reversal or the opposite system developed in the atmosphere to the cyclone, that is the anticyclone. It is a clockwise moving or spherical circulation in the north atmosphere and clockwise anti-clockwise in the southern hemisphere. So the cyclonic condition is responsible, useful for the rainfall. So this area, the chances of getting the rainfall, this area, showing the all these blue area showing the getting the chances of rainfall, and the anticyclone, there is chances of less rainfall. So the pressure distribution of and characteristics of the anticyclone. So pressure distribution, temperature distribution, distribution of moisture and clouds, and distribution of rainfall, wind velocity and direction, and eye of the cyclone. It's depend on the or it's decide the intensity of cyclone or anticyclone. These are the characteristics of the anticyclone or cyclone. This is the anticyclone. This is the cyclone. Suppose you ask, give the short notes on cyclone and anticyclone, or give the differences between cyclone and anticyclone. You sketch the diagram in such way. So instruments used for the measurement of the atmospheric pressure, that is 14 barometer. So many YouTubes or the many material available on the internet. YouTube also the good videos I have already seen regarding the pressure and measurement and instrumentation. So new Q-type pattern of the barometer. This is a 14 barometer. This is a Q-type pattern barometer. This is movable. This is non-movable. This is another one outside of the box. Then aneroid barometer. Here are the different types of the barometer is available now. Digital barometer also available in the market, but this is a standard type of the barometers from which we can understand the. So this is the barograph, from which we understood the pressure of a particular place, and according to that, the IMD or any forecasting institute can, according to this pressure, can judging the rainfall is occurring or not occurring, because you have seen here the if atmospheric pressure at the sea level, that is 760 mm, means the there is a clear sky, and if you are going to reduce or going to decrease the below 750, means there is a chances of the cloud formation and rainfall up to the 740. And some articles already I have shared with you. Again, I will going to share these articles in which given the how it is useful, how to measure the relative humidity, because more relative humidity present in the atmosphere means, and low temperature is there, there is the chances of the different pathogenic and pest attack. If the relative humidity more, means the pressure is less, temperature is more, means the pressure is high. So it is related. Relative humidity depends on the pressure of the atmosphere also, and according to that, the different development of the crop, growth of the crop, disease and pest based on the temperature and the water content in the atmosphere, and it may be indirectly understand from the atmospheric pressure. So the atmospheric pressure is also useful study for the purpose of not only for uh, workout or to give the forecasting of the rainfall, but it is also useful to forecast of the cloud. Cloudy condition always favors to the disease and pest, and photosynthesis rate is decreasing. So atmospheric pressure role in the agrometeorology is also important, and hence we have tried to see the atmospheric pressure and its different components and instrumentation regarding related to the agriculture. Thank you. So any question regarding this before the going to disconnect our or over the time now within 2-3 minutes. So any question regarding this? Any feedback? Yes.
So please explain coal once again. Recent coal. What is
Okay.
coal?
Okay. So these are the two different places. Suppose this is a place of the where you are now?
So Jharkhand.
Jharkhand, okay. And I am in Maharashtra. Okay. Suppose this is a Jharkhand and this is a Maharashtra. Okay. Two places,
sir.
the pressure is high. Is it right? In between that,
Yes, sir.
the Nagpur is there in central from Jharkhand to place of the Aurangabad or Raipur. Okay, we are just consider for the example Raipur is here. So here is the pressure is high, here is high, and this side the low and this side is low. This is the in the atmospheric phenomena. This is not on the surface exactly on the earth. Okay, this is in the atmosphere some up to at some altitude. Is it right? So what happened?
Yes,
Here is a high and here is a low. What happening here? The wind is blowing from this high pressure to low pressure. Again, from this here, from this side, this is flowing from high pressure to this low pressure. Is it right?
Yes, sir.
The same for this place. What happening at particular days? The wind is blowing like this. Means ridge is more here, high. and trough is more here. This is the ridge. Upper means high pressure means ridge. Low pressure means
Okay.
trough. Right?
Trough.
Okay. So what
Yes,
happening?
sir.
That going to like this circular curvilinear. Is it right? Then speed is here is more. Here is a less. Here is a less. Here is a less. And here is near about the balance. Again, here is high pressure, then less, then less, then less, near about neutral. So this neutral pressure place is called as the call.
Okay, sir.
Is it clear?
Yes, sir.
Anybody? Anybody from the class? Anything? Okay. Any question?